Okay, can you see my screen now? And can you hear me as well? All right, let's now begin. Let me just open Jamboard. Okay, we are now heading to the first question. By the way, before we start, I cannot guarantee you that the same set of questions might be present in the IB exam, but sometimes the skill is the same. So the more you are exposed to these skills, the more you're exposed to these kinds of problems analysis, then you'll have higher chances of acing a greater score during the IB exam. Again, I'd like to remind all of you that this is what IB is using or following. So out of 55 questions to be answered, 55 marks to be covered or answered in 1 hour, it is but normal for you not to finish it. But if you look at 62%, which is the minimum score for 7, it's just about 35 points, if I remember it right, the one I told you this morning. So all you have to do is to know what level you wanted to achieve, know the minimum number of marks that you need, and work on achieving those marks for you to get your desired level. All right, so don't be pressured of finishing everything, finishing all questions. Rather, focus on accumulating enough marks to reach your target. All right, so it will be a bonus if you can finish all. That means you have greater chances of getting your desired level, but you have to be wise sometimes. So you have to focus more on accumulating enough points. Okay, so this time, let's now continue with the first question. It's the first question in the past paper, but this is the second problem. This is the problem which I told you to do second. All right, and for this, you will need your calculator. Okay, let's begin with the question. So I'll give you a few minutes to look into the question and try to understand what you need to achieve on this. All right, let's start. So um, this situation talks about the number of days it takes for the computers to be infected by a virus. T talks about the number of days, while Q of T talks about the total number of computers that have been infected given a specific amount of time, which is in days. Okay, so in this table here, you can actually make some sort of markings or some sort of notes in your paper later on. You can say, for example, just in case you will be confused, or just in case you are not familiar with the T and the QT, you can refer to this as your X and you can refer to this as your Y. All right, but you have to know the final answer should be in the form P and Q of T, not X and Y. Okay, IB is quite particular in using the correct notation. Let's start with letter A. Find the equation of the regression line of Q of T on T. All right, so do you know how to use your calculator for the regression line? Okay, so can you do that? Try to do that first on your calculator, and then afterwards, I'd like you to post your answers here. Like how much did you get or what equation? So maybe you can work it out on a paper, take a screenshot, and paste it here on Jamboard. Okay, how much did you get? Or what is the equation of the regression line? Mhm. Point 39, yeah? So in this case, you can have 2 or 3 decimal places if there's no instruction as to how many. But if there is, like how many decimal places you have to round it off to, then you have to follow that. So can you tell me, Phoebe, what you did here? Say if this is the calculator, this is now the data. What should I do next? Yep. Okay. So here we have line 1 and line 2, and then we just... Did you do anything on the store or something here? Nothing? Okay, calculate. So we now get this one. Ah, it's different. Wait, let me check. I might have committed a mistake in the data. Edit. Let me check if I got it correctly. Sorry. 10, 20, 15, 90, 20, 403, 25, 1806, 30, 8070, 35. Oh, here. This one. This must be 35. 35, 35. 40, 3267, 40, 120146. All right, let me check. So stat, calc, and then linear regression, and then calculate. So this is our A, this is our B. So that would be 3094.28. And then don't use X. Go back to what I told you a while ago. You can have X, but the final answer should be according to what is found here. So in this case, it's what variable should we use? T. Okay? And then your y-intercept is negative 54042.39. So if you're going to write it here, you have to use the correct notation. Okay? So this must be q of t. Remember, we are not using y. We're using here q of t is equal to, we have 3094.28t minus, you have 54042.39. So this is now our linear regression. Do you follow? All right. Now, here's the problem. The problem here is in number 2, you are asked of R, Pearson's product moment correlation. How do you find this? It's not written here. So how do you find it then? Any suggestions? Yes, please, go ahead. How do you do it? I think I've heard a notification just now. Yeah, go. Go ahead, Kenneth. Catalog, this one, the 0. Yeah. And then, very good. Look for diagnostic here. Diagnostic actually gives you other diagnostics, meaning other data aside from what's given. So go for diagnostic on. So again, everyone, first up, what you're going to do is look for the button with the catalog. In my case, it's found on 0, which is in blue colors. So click on that and then look for diagnostic on. Then press enter and then press enter again. It says done. Got it? So after that, run the linear regression once more. Try to see what happens with the values given. So you now have here the value of r, which is what we were looking for. So try to confirm if you're able to get this one as well. If not, you can ask for questions, you can ask for help and assistance. Okay, so we now have r equal to 0.75. Questions, clarifications, or please confirm if we can move forward. No questions? Everybody got the process? Please confirm. It's okay. No questions. Joel has confirmed already. Yeah. Okay. Let's proceed now. Now, before we proceed to the third one, it's better for you to understand the meaning of R, the product moment correlation. So, what do you mean by the correlation? What is the meaning of the value of 0.75? What does it tell you? Or based on your previous discussion when you were in grade 11, what's the use of correlation? Of R, I mean the coefficient. Anyone? What have you remembered? Who remembers? What's the use of the R? The R will determine whether the correlation is positive, whether the correlation is negative, or there's no correlation at all. All right? So when we say correlation, it talks about the causality, meaning causality means the cause. So the occurrence of T will cause the occurrence of Q of T. So in other words, it doesn't give you a certainty. It doesn't show you any certainty at all. It just shows you causality, meaning causes. It may cause. So as we increase the number of days, it may result to an increase as well in the number of computers infected. In that case, as we increase T, we observe an increase in QT. That shows you a positive correlation. If it's the other way around, that shows you a negative correlation. So it tells you whether two variables have a tendency to affect one another, or it tells you whether the independent variable can cause the occurrence of the dependent variable. And the value of the correlation tells you the strength. Are you familiar of weak positive and strong positive? Have you had this discussion before? Yeah. So there's a certain bracket. There's a certain how do you call this one? Interval for us to say it's weak positive, it's strong positive. From the word itself, weak and strong, it tells you how much Q of T may change depending on the change in the T. Likewise, it's also possible for the correlation to have no correlation at all, depending on the result of your R. So that's the use of the coefficient of correlation. Now, here's the thing. This coefficient of correlation is based from what kind of regression based on our answer here? It's based from a linear regression. Now, this time, before we proceed with number 3, I'd like you to look into the graph of this table. Do you know how to check the graph of this table? Do you know how to check without inputting it? We have inputted already. Do you know how to check? For those who do not know, press on this one. Why? Wait, let me just change this one because I've... Wait. Okay, here. Again, this one, clear. Sorry. So for those who do not know, what you can do is you can press second and stat plot. Check on stat plot. All right. Second, stat plot. Then, if you notice, our data was encoded under L1 and L2, right? So you can just choose this one, the number one. All right. So plot one on, and then we're going to use the scatter diagram. All right. Then the list is L1 and L2. Then this one color blue. Okay. So that's how to graph the table of values that we have inputted in statistics. And then for the window, we just have to make sure to show the values. So if you recall, the values here for the t has a minimum of 10. So for the x, we can just have it as 0. And then maximum value here is 40, so I can just put it as 50. Scale is 5, so I can just adjust it. Anyways, I just would like to know to check the trend. All right. And then for the y, the smallest value here is 20, so I can just put here 0. The maximum value here is 120,000. I'll just put 130,000. Sorry, 130, 123. Scale, maybe I can write 10,000. Let's just try to see. Okay, 10,000, this one. Okay, and then I'd like you to check on the graph. Now look at the points itself. Looking at the by the way, you can check on whether the points are correct if you try to travel from one point to the other. Wait, sorry. Sorry, trace. You press on trace rather. So when you click on trace, you can actually check if the points are plotted correctly. So this is 10, 20, 15, 90, 20, 403, just to check if it's correct or not. 25, 1806, 30, 8070, 35, 32667, and 40, 120, 146. Yeah, correct. So look at the trend of the points. Do you think this forms a linear trend? No, it doesn't, right? Clearly, it doesn't. We're just doing linear regression because we wanted to find the line of best fit. If it was linear, we are trying to find the line of best fit. Thus, we use linear regression. But when we checked on the points when they are plotted, the points may not or doesn't really follow a linear trend. Do you get it? So before we proceed, questions on the plotting itself? Because I think I've seen a lot of questions on statistics in paper 3. Questions on plotting? No question? And now we're ready to answer number 3. So why do you think it's not appropriate to conduct a hypothesis test on the value of R? Remember, where did we get R from? It's from the... Exactly. So why do you think it's not appropriate then? Okay, very good. But we are not sure if it's quadratic as of the moment. Right? We are not pretty sure. So we can just say that the graph shows a trend that is non-linear. Let me just write it here. So the graph shows a trend, a non-linear trend. Let's make it this way. Non-linear trend, and R was derived or used to measure or from what kind of regression? Exactly. Or we can say linear correlation. So because your graph doesn't show a linear trend, therefore we cannot actually let's say run a hypothesis test because this won't be like it won't fit. It's not appropriate at all. All right. So that's it. Questions, clarifications. I will allow you to take a look at this first and try to understand the situation before we proceed to the next. Is the first part clear, everyone? Okay, thank you so much. This time, let's proceed to the next. And here you might see something that's familiar. Okay, so I'll give you 1 minute to look at the problem, look at it first, and try to understand what this is all about. All right, let's begin. I'd like you to look at this given equation here and tell me what kind of equation this is. So what kind of equation is this? The general term for it. Look at the symbol. Look at the symbol here. So what kind of equation? It starts with letter D. No, yeah, yep, but we have another term for a derivative used in an equation. Yeah, very good. This is a differential equation, okay? And you have to know how to rewrite a differential equation, okay? So if you remember, in this differential equation, we have variables t and what? Q of t. Do you follow? Let me just encircle it. T and Q of t. You can actually think of it as, for those who are confused, for those who are not really comfortable, which I do understand of differential equations, you can think of it as x and f of x. Do you follow? So if I can rewrite f prime of x as, how do I rewrite this again? Using y and x? No, no, using y and x. F prime of x is the same as, if you remember, it's the same as d blank over d blank. dy over dx. Do you follow? F prime of x is equal to dy over dx. Therefore, q prime of t will just be equal to what? No, we don't use y and x. Remember that we're using a different variable. Very good. So we can now write it as dq, this is our y, all over dt. So this is something that you have to know and to understand. Because when you do solve differential equations, you need to separate them. Okay? So from here, we can now rewrite this as dq over dt equal to beta times n times q of t. Or you can just write it as q if you wanted to. All right? So for the first one, you are going to find the general solution of this differential equation. Remember, there are two types of solving it, separable and non-separable. Now, before we begin, look at the nature of b and n. Are they variables? Are they constants? What are they? We have to know that also. What is the nature of b and n? They're constants. So treat them as numbers. Don't treat them as variables. All right? So try to check, are they separable or not? I'll give you time. Write it on your notes. Try to solve this one. And then I'd like the following to post their answers. Okay, just try your best. Let's have Kanya and Kenneth is done this morning. Sam is done. Joel, you're done also, right? Yeah, Joel and Kanya. You don't have to get it correctly. It's fine if it's not correct. Just try to solve this differential equation and post your answers here for us to see. The rest, try it out in your notebooks also. If you are stuck along the way, you can ask me questions, no problem. This one is from Kanye, I guess. Correct? Yeah, okay, thank you so much. Okay, thank you so much. Let's try to check your work. Let's try to see how you're able to do this. Let me start with Joel, Q of T, and then ln of Q, B and T plus C. Okay, E, this is now Q. Okay. While the other one, we have one over y, ln y, so E, so y is equal to, wait, all right. Um, just two suggestions, okay? First suggestion is for Joel, and this goes for everyone as well. Um, here, wait, let me just write this one. Okay. This one is actually okay. This part here. Sorry. This part here is okay. I think Kanya also has the same answer here. This one is okay, which is the same as what Kanya has in her answer here. So more or less it's the same. We can actually further separate this as what Kanya did. It's Q equal to e raised to beta n, and you have here t plus, or times rather. If you use the law of exponent, this is multiplied with e power of c. Right, Joel? Yeah. But then, this e to the power of c will still be a constant. It's another constant. So we can assume it using another letter. So as for Kanya, don't use the same letter so that you won't be confused maybe perhaps. So you can just say let A or let M or R, P equal to E power of C. So we can write this as Q is equal to P. Then you have E, B, beta, and power of P. So it's the same as what Kanya has written, only that I'm using another letter here. Clear? How about for the others? Yeah. Although in the marking scheme, if you try to look at it, this one is already accepted. This part here is accepted as well. This one. Okay, this was considered a general equation. But just to be sure, because if you try to use ln cannot take negative values. Ln of a negative is an error. So that's the reason why we need to keep ln. We need to keep this positive. That's why we are having an absolute value. Unless we are sure of the value of q, we have to put in an absolute value. All right? So that's it. So this is not a general equation. Any questions or clarifications? No questions? By the way, this kind of separating differential equation is common. I haven't seen in the past papers solving differential equations that are non-separable. If it's non-separable, it takes a longer process. So if you take a look at your notes, we had a discussion on that. It's a longer process. But usually, I only saw questions on differential equations that are separable. Okay, but just to be sure, just try to review on the non-separable ones. All right, let's now proceed to the next one. Now, this one is not. This is not linear. So using the same data in the table, what do you think is the appropriate equation for this nonlinear regression model? I think you'll have an idea based on this. P is just constant, right? P is constant. Is it correct? So look at this equation. What kind of equation do we have? Wherein our variable t is an exponent of something. So what kind of equation is this? Exactly. So it's not quadratic. So based on this, we can say that we have to attempt on using not quadratic regression, but we are going to use exponential regression. Yeah. And I think you can find exponential regression in the same, I think below the linear regression, you just have to find it. So I'd like you to use your calculator once more. Give me the equation of the exponential regression and the value of r squared. So right now we have already turned the diagnostic on. So I think automatically you'll get the capital R squared. So maybe I'll give you 1 minute to do that, and then I'll call on somebody to give us the equation of the exponential regression. By the way, there are many ways of writing the exponential regression here, but in my case, I would rather follow the GDC, the ones that I found using the calculator, because all throughout my solution, I am basing it from the calculator itself. So I would easily understand and explain it if I pattern my answer based on one source or based on the material I'm using. So if you have another answer for this, please try to check the answer marking scheme. If it's one of the suggested answer, that's correct. Okay. All right. Let's check. Can we have Kenneth? Kenneth, what is the equation that you've got that you were able to derive there? The exponential regression. So just to help you, let's try to run exponential regression here. So calc 0, same thing, calculate. Yeah, this is what we see. Okay. Can we first interpret this one? In the calculator, it's generic y equal to a times b to the power of x. But according to our given here, how do we rewrite this without substituting the values yet? What is our y again? Y is what? How do we represent the y here? Anyone? How did we represent the y in our problem? Very good. So q of t equals, you have there a times b, and then x was represented as, sorry, t. Thank you so much. Represented as t. And from the calculator, a is equal to, maybe you can look at your calculator there, two decimal places, 1.15, correct? And b is represented as 1.34. Okay. So these are now the values that we've got based on our exponential regression. So from here, we can now determine our equation of exponential regression. So q of t is equal to 1.15 times 1.34 power of t. Okay, so this is now our equation. Question? And I think it's easy to find the value of r squared. Yeah, Kenneth, I'll go back to you. So what is the r squared that you've got there? Very good. That's your r squared. So if you try to look at it, automatically you can get the second answer correctly. This is what r squared is equal to. Okay? So we're now down with the first two questions. We're now going to the fourth and the fifth. So comment on the suitability of the model in comparison with the linear model in part A. So first, we are asked to compare and to check which one is a lot more suitable. All right? So if we are to compare, what are we supposed to use? What values are we supposed to compare? We are supposed to compare the parameters of both results of regression. The parameter is actually your r. It's either you compare the r's or you compare the r squared. It depends. You cannot compare the r squared that with the r of the other or the r of exponential with the r squared of the linear. It should be the r with the r squared with the r squared. So if you're going to stick with the r squared, so we compare exponential, let me write it here. This is exponential Okay, and this is your r squared, and then we have the linear regression, and we're getting the r squared as well. So if we try to look at it for the exponential, we actually got 0.999. For the r, let's go back. What value of r we were able to get? It's 0.75. If you square this one, although if you run linear regression once more, you can get the value directly. You will actually get 0.563. Okay, 0.75 squared. So this is actually 0.563. Okay, so how do you compare the two? Which one is greater? The r, it's the exponential. Do you follow? And if you try to look at the values here, this tells us, the r squared tells us that as we increase the time, which is in days, we should observe a greater change in your q of t. The change here is not linear, it's not constant. The change here is non-constant. The change here is non-linear because as t increases by the same amount, your y, your q of t, in the change in the q of t is not constant. And looking at the trend of the change is actually greater as we increase the number of days. So based on the values of the r squared, we can say that since the r squared of the exponential is greater that with the linear, this exponential somehow represents the real situation. Do you follow? Because based on what we have observed here, the change is greater as we increase the number of days. So this speaks of the situation that is observed based on the table. So we say B, the ones we're doing now in B is a lot more suitable than the ones we're doing in A. Again, you can use the difference, the comparison between the two r squared values. Even if you use r, this will still be greater than this. And that is, and you can support it with the trend that you are seeing in the table. The change here grows even more as the number of days increases by the same amount. Okay, and that is actually represented by the r squared. All right, so those are enough evidences to, let's say, to, how do you call this one? To conclude that the second model, the exponential model, is suitable. Okay, now next, let's go back to, are we given the population class? Let me check. The population of computers. How many computers are there? No, we don't know how many computers there are. All right. So anyways, for the last question for this letter B, I guess, this is letter B. By considering large values of t, meaning as we increase time, what if we do 1 year, 2 years, 3 years? What could be one problem for this particular exponential model? So we now have an exponential model, and we know that in the exponential model, as we increase the number of days, as we increase time, your y changes um, with a large value, with a large interval. I mean that the change in y is abrupt. It's great, it's very high. All right. Now looking at its graph, let me look at the graph. Look at this one. This is only up until 40 days, and this is how much computers have been infected. All right. Looking at this, what could be a downside? What could be a criticism? What happens if we increase the number of days to 2 months, 3 months, 4 months, 1 year? What happens? The growth? Very good. The growth, meaning it tells us that as we increase the number of let's say, days to 2 months, 3 months, 4 months, the number of computers infected would be very high. It would be greater. In fact, if it's only 40 days, it already reaches 120,000. How about if it's 2 months or 1 year? So if this is correct, if this is true, then it tells us that there will be a point in time wherein the number of computers infected could be more than the population, because the population of computers is finite, meaning it's not infinite. We have a specific number of computers infected. In a certain place, for example, we cannot say that there are a limited number of computers. Computer is a resource that can be depleted over time, meaning we can tell how many computers are manufactured in a certain location. But here in this model, it tells us that the amount of growth is infinite, because as we increase time, the growth also increases too much. So there might be a point in time wherein, using this model, the number of computers infected could be even greater than the real population. And that is the downside of an exponential growth. It doesn't perfectly mirror the real situation. Do you follow? So that's only one criticism that we can get. So if we try to put a note here, we can say, in let's say, increasing time to larger values may result to number of computers infected to be even greater than the what? Exactly, the real population of computers, which is impossible. Okay, so there's no end, and in this case we are not given a specific boundary, like from time of this and that. There was no boundary given, so we assume that time here is infinite as well. Okay, and that's it. Questions? Clarifications? Yeah. Okay. Let me check. I think I'm recording this. Yeah, I am. All right. Let's now proceed to the next one. Next problem. How about the others? Do you have any questions before I proceed? You might have something that you want me to explain further. Yeah. Okay. Let's move forward. Thank you so much for the confirmation. Let's proceed to this one. So use your answer from part B to estimate the time taken for the number of infected computers to double. I won't teach you on this, but rather I'd like you to work on this one first. So recall that this is the equation we were able to come up with a while ago. Q of t is equal to 1.15 times 1.34 t. Okay. All right. So what you're going to do here is to estimate the value of t at which the number of computers, the number of infected computers will double. I'll give you a clue. Find q of t when t is equal to 0. You can always do this. All right? Find q of t when t is equal to 0. This will be your basis. And then from there, do something, do an experiment, try to double the q of t and find out what time is equal to. Okay? I'll give you some time to work on it, and then I'll be waiting for the answers of Jovita, Phoebe, Sam, and Jeremy. Okay, you can post your answers here. It doesn't have to be correct. That's the reason why we're discussing, because we wanted to somehow correct some of your answers. Again, find q of t when t is equal to 0. Use this one. Okay? And then try to modify the value of q of t such that it becomes double of what you've got, then solve for t. If you have another strategy, you could also use that. You don't have to follow this one. This is just one of the strategies. Okay? Maybe I'll give you 5 minutes to work on it. Proceed. So I'm giving you a clue and a guidance here for you to know what to do. Yeah, very good. Okay. Yes, very good. Excellent. Very good. Who posted this one? Very good. So you're using numeric solver. So I really encourage you to maximize the use of the calculator because we need a lot of time. Okay. All right. I think this is enough answers that we have. Sam, can you explain your work, please? Can you just share what you did? Very good. So you don't even have to simplify this. Or if you want, you can simplify this if you'd like to before you use numeric solver or GDC. Very good. So t is equal to 2.37 days. And I think who wrote this? Is it Phoebe? Oh yeah, it's okay. But who wrote the one on top? Kenneth? Okay, thank you so much. Very good. Okay, both are correct. I think Phoebe also got the same answer. Is there anybody here who has another solution? Another way of answering this? Any suggestions? Because what we wanted only here is to find the time when the number of computers will double. So we can actually do something else without using this. What else could we do? Anyone who would like to share? No one? Let's proceed. Okay. By the way, when you try to substitute values here, please don't use these values. Can you see my screen? I'm sorry. Yeah. When you do exponential regression to this, here in your calculator, it shows like this, right? When we do exponential regression, the graph may not perfectly pass through each point. You're familiar with line of best fit, right? Are you familiar with line of best fit? If you do line of best fit, it's not an assurance that that line will pass through each of the point. So there's no guarantee as well that the exponential regression, the graph, will pass through all these points. In other words, do not use these points. This may not be appropriate for this because we're just getting the trend. So the trend is exponential, and from that trend, we got this equation. Okay? So what's another way of doing it? Our goal here is just simply to get double, to find a time when it's double. We can actually, hypothetically, just randomly choose y values. When I say choose y values, I can write here I can write here t and then q of t. And can you give me two specific values of q of t wherein one is double the other? Any. You can give me any values of q of t. Okay, let's start. Javita, give me your favorite number. 10. Let's say I'll assume q of t to be 10. So if we double the 10, what should be the other q of t? 20. Do you follow? Because we just wanted to see what happens when we double q of t. So using your equation, solve for t then. So let's try to use 10. Okay? So I'll go back to my numeric solver. Q of t is 10. Do you follow? And then my equation is 1 point, sorry, let me clear this one first. Clear. 1.15 times 1.34 to the power of, let's say, let me do this. Power of x. All right, let's have this one. So 10 equal to 1.15, that's 1 to the power of x. So graph. So we got 7.38998. Let's just have 5 decimal places, 7.38998. So this would now be, let me use red one, 7.38998. Was it correct? 7.38998? 998. All right, that's correct. That is the time it takes to get a q of t of 10. What's the other value of y again? 20. Okay. So again, this is just hypothetical because we just wanted to check what happens to the time it's doubled. Okay. So I'll graph again. I got 9.75. Let me just copy. 9.75, 834. 834. Okay. Try to see. These are the values that we've got. So how long does it take for this to be achieved? Given that 10, it takes 7.3839 days, and then 20, 9.76 days. Can you use your calculator, please, and compute for the difference in the time? Okay, can you tell me here what's the difference? Correct. So it's still the same. Do you get it? Yeah. So you don't have to be very technical on this. So you can also think of a wiser way on how you can do this. I have to be very honest with you. When I try to work on past papers, I first answer it on my own. Then I'll try to look at the marking scheme and compare. And from there, I'll try to find another way. When I worked on this is what I got first. When I look at the marking scheme, oh, okay. Yeah, I think I can get the value of Q of t when t is 0, then do it afterwards. So this process this one, I got this from the marking scheme, but this is my own method. So what does it mean? We don't have to be very technical when we solve this one. Sometimes common sense is also needed. So you just have to understand what you need to achieve. What do I need to get? What should I do? And so on and so forth. All right. I also encourage you to check on marking scheme, not on the answer, but on the process. Focus on the process, not on the answer. Because if you are familiar with the process, when you encounter similar problems, at least you would know already on what to do and how to attack that particular problem. All right? So that's it. Clarifications and questions on this item? If none, can we proceed to the next now? All right, let's proceed to the next question. This is now question letter D. Okay, I'll give you a minute to read and understand what you're supposed to do here. Okay, let me just copy, sorry. Let me just copy this one. I'm sorry, I just have to wait, go back to this. Because I think this will help you answer. All right, so here, what are we trying to find in letter D? Anyone? What are you supposed to find in D? You read first the question and then try to find the word that is what you are to find. So we are to choose between X and Y according to what? According to, yeah, according to which between the two does the virus spread more easily? So the key term here is the word more easily. Now go back to the previous equation. That's the reason why I pasted this one. Which quantity talks about more easily? It's what? Yeah, the constant, which is your beta. Now, can I equate the word more easily to fastly or more faster or a lot faster? Remember the times when we had COVID? They said that the Omicron virus spreads easily than the other, um, how do you call that one? Than the previous ones. So when we say easily, will that be equated to fast? How fast it is? Are the two the same? More easily and fast? Okay, let's say Omicron virus. It spreads easily. What does it mean? Exactly, easily to get spread. Maybe if the previous, how do you call those? How do you call those previous? There's a term for the viruses. Previous, not strand. Previous blank of viruses. Variants. The previous variants. Okay, the previous variants. If you try to remember, um, if in case you are, let's say, a meter away from an infected person, there's a chance for you not to get infected because we do, um, how do you call this one? Distance. We distance ourselves from the other person who's infected. So at least 1 meter away, we are safe. But Omicron virus might be different because even if you're 1 meter away, you could still be infected by the virus. That is why we say Omicron virus spreads easily. And sometimes there might be other mediums at which the virus can spread out, not just by means of air, for example. So the word easily does not only talk about time, it also talks about how the virus can spread out. Do you follow? Time is just one element, but not equivalent to the word easily. Now, why am I saying this? It's because most of the students might think that if the virus spreads easily, we can say it's also fast. It depends. Easily is talking about the medium. It's like talking about how the virus can be spread to or can be can be spread out to the others, can infect the others. But it doesn't necessarily talk about the time. Do you follow? So don't equate easily with time. All right? So they are not actually synonymous. They're not the same. Is that clear? Yeah. But one thing is certain here, we are going to compare the beta between the two. The higher the beta, the more easily the virus can spread out in that particular region. So what we know here is we have here CPY. Okay, let's just do it this way to make it clear. Let's say the value of, okay, this is the value of beta. This is in CTX and this is in CTY. We know already that in CTY, beta is equal to 9.64 times 10 to the power of negative 8. But we do not know the beta in CTX. Okay? Now, a while ago, we were able to come up with an equation. Let's try to find it out. This one. Okay? I'd like you to use this equation in order to solve for the beta. Knowing that the population is 2.6 million. So let me just take a screenshot of this. It's up to you on which one you would want to use. Okay, take a screenshot, post it here, and then I'll call somebody later on to post your answers here. Or anyone who's ready, you can post your answers here if you wanted to. Sorry. So these are the equations that we got a while ago. Use these equations to solve for the beta for CTX. All right, proceed. All right, anybody who was able to answer it, you can post it here. or what seems to be the problem? What is that thing that you encountered which makes this quite challenging? Anyone? No one? No one was able to get it? Okay, wait for a while. I'm actually, I just realized right now that I could have another solution, which I will share with you. Allow me to test it out. Although I already have an answer, I just would like to share another solution. I just realized it right now. Let me check if this works. Yeah, it did work. All right, let's proceed. So I have here two solutions. The one that I answered a while ago and the one that I just answered right now. Okay, I will be using, let me erase this. All right, then I will be using the equation that we've derived just now. So based from this, we can actually see that I'll use the one that Kanya got and Joel as well. Q is actually, let me just erase. Q is equal to, we have here P E to the power of beta, N, and T. Do you understand this one? Yeah. For us to solve for P, we need to find, or we need to use what value of time? Initial. Therefore, time is, yeah, we need to find that time is equal to 0. When time is equal to 0, do we have a value of Q? Did we have a value of Q? We had, right? And what's the value of Q? Exactly. So these are now the things that we can use. So we can now say Q is, sorry, let me erase. I'll just go directly to the answer. So we can now say substitute the values. We now have 1.15, that's your Q, equal to P. Because this one would be equal to 0. Follow? Do you follow, everyone? So from here, using the data from CTX, we can now say Q is equal to 1.15 e to the power of beta, N, times t. So this is now the equation that we've had. Question, clarification? No question so far? Okay, this time let's solve for n. So to solve for n, before we do any substitution, let's try to change the subject to n, meaning solve for n. To solve for n, what should I do first? Use your algebraic manipulation. Let me erase this one. Anybody, any suggestions? What should I do to solve for n? Should I take ln right away or should I do something first? And what is it? Anyone? Basic algebra. I wanted to solve for the n, so I should eliminate other values, other variables. In this case, I should what? Divide both sides by what? Divide. Exactly. Divide both sides by 1.15. So this now becomes e power of b and p. Allow me to switch them. It's just the same. Q over 1.15. Okay? But there's an e. I have to eliminate the e. So what should I do? ln. Very good. ln. Okay? So this now becomes beta and t equal to ln of q over 1.15. How can I solve for the n? N is equal to what? Q over 1.15 divided by beta n, right? Or times 1 over beta n. It's just the same thing. Do you follow? Everyone follows? Try to see first before I continue. Questions? Please ask questions. No questions? Can we proceed? Okay. Now, this time, to proceed, we need to have a known value of q and t. Sorry, I think something's wrong here. This is not bn, this is b times t. A known value of q and t. Did we have a known value of q and t before? What is it? At t equal to 2.37, the n is doubled and the value was, okay. This time, it's now your turn. Use these values and solve for n, and that's it. All right. So what's the value of n? Anyone? Sorry. You don't need a numeric solver for this. All you have to do is just to substitute the values. Yeah. Yep. Ah, sorry. Thank you for that. Yeah, it's not the n, it's the q. N is the one that we're looking for. And sorry, I think there's something wrong. If in case you are confused, please tell me. Yeah, we're not solving for the n. We're solving for the b, for the beta. Wait, let me just check. Okay, here. I'm sorry. This must not be the n. I just noticed it now. Sorry. This is the beta. We're solving for the beta, and this one is your n. So this is now, yeah, n. This is your q. This is now solved for beta instead. Okay, I'm sorry for that. Please try to check if there's something wrong. Please tell me. Because we're comparing the beta of x and y. All right, so what value of beta were you able to get? Okay, so we have here 1.12. So beta here in CTX is 1.12 times 10 power of negative 7. Now, if you try to look at it, the exponent here is negative 7, so the effect is different. If it was positive, the bigger the exponent, the bigger the value. But because it's negative, it's the other way around. The closer the exponent to 0 for the negative, the bigger the value. Do you follow? Because the negative 7 tells us that there are 7 decimal places, including this one. Here, there are 8 decimal places. Yeah. So in this case, which one is greater? The beta of x or the beta of y? If you're confused, you can subtract both. When you subtract the x and the y, if the result is positive, that means x is greater. If you subtract x and y and if the result is negative, that means the y is the one that's greater. So you can do that. Or you can look at the exponent. So from here, which one is greater, x or y? The x, right? The beta of x is greater. So since x is greater and since beta tells you the how easily the virus spreads, so which between the CT is the virus spreading more easily? Yeah, that's why. Therefore, the answer to this it's now CTX because beta in x is greater than beta in y. Okay? So beta sub x is greater than beta sub y, or the beta in x is greater than beta in y. All right? Questions and clarifications? How about the others? Because I can only hear Joel responding. How about the others? Any questions, clarifications? Yeah, okay. This time, let's proceed. Let's now have this particular question. This is now question letter E. All right, I'll give you maybe 3 minutes to understand what this question is all about. Okay, so letter E is just a simple substitution. If we try to look at it, to solve for A and B, we just have to follow this formula. So this formula tells us that the value of q prime of t will just be the q within that particular, let's say, parameter, the q of t plus 5 subtracted by the q of t minus 5 over 10. That's the value of q prime of t. So A is actually the value of q prime of t when q of 15 is equal to 90. Okay, so this we can say q of 15, so t is 15. So q of 15 is equal to 90. And we wanted to find the q prime of 15. Look at the formula. It says q of t plus 5. So if q of t is 90, that is t is equal to 15, what do you think is q of t plus 5 equal to? Very good. So if we wanted to solve for A, okay, so here A is equal to, we have q of A belongs to what time? Or A is the value of q prime of t at what particular time? A, no, not 20. 15. That's for A. So A is equal to q of 15 plus 5. So try to see this one. Do you follow? Is it clear so far? 15 is the t for A. But then the formula says it's q of t plus 5. That means 15 plus 5 minus q of, this will be what? Over 10. So this is now equal to q of 20 minus q of 10 over 10. So just a simple substitution. Q of 20 is 403, correct? Q of 10 is 20 over 10. And this gives you a value of 38.3. This time, I'd like you to work on letter B, and I'll call you at random to give me an answer. So I'll call students at random. So make sure that you know the answer to letter B. And not just the answer, I'd like you to give a screenshot of your solution as well. All right? 3 minutes, proceed. So solution plus answer. So please get ready. Jeremy, if you're here. Jeremy, by the way, can you hear me? Kenneth, can you still hear me? Yeah. Sam? Yeah. Phoebe? All right. Sam and Phoebe, please share your answer later on once you're done. All right. You can now show your answers if you're done. This one is coming from. Yeah. Okay. It's okay. No problem. Allow me to go to the next question to prepare. Yeah. 3086.1. So we have to make it somehow more accurate. So both are correct. Just need to give one or two decimal places for this one, Phoebe. Okay. All right. Thank you so much. So I think we don't have a question for this one, right? Everything is clear. So not much higher discussion for this. All you have to do is just to read. That's why I'm telling. This is what I'm telling you, class. Um, you might find the earlier parts difficult, but in paper 3, there are some parts towards the end that might not require a lot of calculations or a lot of analysis. So you have to look for it, okay? Because paper 3 is composed of different situations. There might be a situation that could be answered um, without connecting it to the previous answers, just like this one. Just like in the session this morning, the matrix part, it's not connected to the previous discussion, to the previous answer. So try to look for it because this will also give you points later on. Okay, can I now proceed to the next? Yeah, let's proceed. And this one. I'll give you 1 minute to understand this one so we can proceed. Okay. Based on this particular line here, let me encircle this one. This particular line here, it is predicted to be a what? What kind of graph? Very good. It's predicted to be a line. It's predicted to be linear. And if you try to look at it, when we try to do linear equations, we always have a y and we always have an x, right? Wherein we expect this to be an x and this to be a y as well. This is the linear regression or linear equation that we usually have. Therefore, if we try to read this one of which should be the x and one of which should be the y. So what are the quantities here that we are trying to plot against each other? We have q prime of t over q of t, and we have q of t as well. So which do you think between the two is the independent and which do you think is the dependent? Analyze. Which one will depend on the other? Very good. Basically, this will depend on the value of this. Do you follow? Because this needs q of t. I hope it's clear. So this becomes your y, and this becomes your x. Is it clear so far before I proceed? Okay. So from here alone, before we try to do any comparisons, before we try to do any lines or any regression, I'd like you to go back to the equation given on top. We have here q prime of t equal to k q of t, all right? Um, Times, we have 1 minus q of t over L, and then this one. So we need to rewrite this in the form q prime of t over q of t, this one. We need to rewrite this because that is our y. That is our dependent variable. So we can only do this by dividing both sides by, very good. So we divide both sides by q of t. Okay. So we now have q prime of t all over q of t equal to, we have k, do you follow? Times 1 minus q of t over L, this one. Am I making sense so far? Is it clear? I'm sorry. Okay. So for you to understand this further, for you to be able to understand it easily, can we change it to y and x? And then later, change it back to q prime of t? Because in this form, it's difficult to analyze. That's one strategy I'm doing whenever I have a lot of variables. Can we use y and x instead? Yeah. So look at this one, the ones in red. Q prime of t over q of t is your y. Q of t is your x. K and L are simply constants. They are values. K and L are constants. Look at this one. So I can rewrite this just to make it simple. I can rewrite this as y equals k times 1 minus x over L. Before I proceed, questions? No questions? Okay. Then we proceed. So this now becomes y equal to, if I distribute the k minus kx over L. Clear? But linear equations come in the form y equal to mx plus c. Do you follow? So it's y equal to mx plus c. So what we can do here is, let's try to rewrite this so it abides to this form. Okay? So if we are to rewrite this, it means it's y equal to, um, since this k and this l are simply constants, we can separate it with the x. So I can just write it as negative of k over l x. Let me just change this one to red one. Plus k. Is it clear so far? We're in this form, the slope is equal to what? Negative k over l. And your y-intercept is equal to k. I hope this one is pretty clear. Okay, stop for a while. Try to understand. If you have confusions, please ask me questions before we proceed to the next step. Clear so far? Can we proceed? Or do you have anything that you would want me to clarify? Okay, so we are now ready for the linear regression. Okay, but before that, we have to know first the content of our table. So if you try to look at it, the content of our table will be as follows. The x is your q of t, and the y will be q prime of t over q of t. Clear? Let me just put a boundary. Okay. Now, sir, where do we get these values from? We will get it from the table. Okay? So we will need this table in order to solve for this one. So starting with the q of t. So on this table, the q of t is, oh, we don't have this, so we will not make use of this. We have 90. And then the q prime of t is, what was the value of a again? 38.3. 38.3 over 90. So class, this is how it would look like. Q of t is 90. Do you follow? And then for this one, the ratio, it's 38.3 over 90. Is it clear? Yeah. So I'd like you to continue because if I will write it, it will take us a much of time. Then it's already about 2:30, 3 o'clock rather. It's 3:01 on my clock. So let's try to put it in here. Edit L3. So here we have 90. And then here in L4, that was 38.3. 38.3 then divided by 90. Automatically, the calculator will compute it. Sorry. 38.3 divided by 90. Okay, that one. So can you complete this one, please? Fill in all the information here. So I'll show you the table. It's q of t and then q prime of t over q of t. Let me just copy this table to the other slide. Let me cover it first. So I'll do this one. Okay, and then I'd like you to do the linear regression thing. Try to see the values you will get. All right, proceed. All right. If you already have the equation, you can now share it with me. You can have 3 decimal places to make it quite exact. Anyone? Do you have the equation already? Yeah. Joel, can you tell me? Negative 2.548 times 10 power of negative 6. Okay, Q. I'll just use the word Q. Yeah. Plus. Very good. This is the linear regression, the equation of the linear regression. All right. So we now have the equation, but then what we are trying to find here is the value of, I think I've erased it. Wait. I think what we're trying to find here, sorry, let me just, okay. What we're trying to find here is the value of K and L. Do you follow? And since we have prepared it ahead of time, so we know already that this particular value, 0.422, is simply the y-intercept. And this corresponds to what variable, to what constant? K. Very good. So from here, we can now say K is equal to 0.422. Okay, this one. And this value here is your slope, right? This corresponds to this. Clear? So we can now say, we have to solve for L first. We can now say negative 2.548 times 10 power of negative 6 is equal to negative K over L. We can just erase the two negatives because both are negatives. So we can just multiply them by negative 1, both of them. We'll get a positive result. And so L is equal to 0.422 over 2.548 times 10 power of negative 6. And this will give us a value of L, which is what value did you get? Try to check. 620. Yeah. So this might be slightly different from the marking scheme. It's because we're using the marking scheme might be using exact values. Here we are trying to um, round it off. So you don't have to worry about a slight difference in the answer. Anyways, the IB examiner will have to look at your solution. 165, 620. Okay, and that's it. Question? Yeah. Okay. So allow me to extend, like it's already 9 minutes. Let me just have 5 minutes more. So this is done already. If you don't have questions, we can proceed to the next, and this will be the last one. Okay. I'll just have to make it quite fast here. So 1 minute to read and to understand before we proceed. So what are we trying to find out here? Yeah, the percentage of infected computers over large period of time or over long period of time. Okay, so how many computers will be infected if it takes a year, 2 years, 3 years, or for longer period of time? So I think the best part here is to identify first how many computers are infected by then, divided by the total population. Okay, so again, we have to find out first the number of computers infected over a long period of time. So um, if we are to simplify this one here, we can now say Q of T equal to L over 1 plus C E power of negative K. And then, how about for the time? Since we're talking about long periods of time, how can we represent that? The word long period of time, it's the same as what? Anyone? This will just be long period of time, very long period of time. There's no specific value, but for as long it's long period. 50, infinite. We can actually talk about infinite because we don't know. We just know it's a long period of time, so we can represent it with infinity. 50 is okay, but then how about if it's more than 50 years? How about if it's 100 years? For as long as it's a long period of time. So we can represent that as an infinity, okay? So this now is equal to L over 1 plus, we now have here e to the power of any negative value. We know for a fact that we can simplify it using a law of exponent, e to the power of k times infinity. Do you follow? Now, whatever the value of k is, if you multiply it to infinity, it will still be infinity. Okay? So we can just write it as L over 1 plus C over e to the infinity, because k times infinity, this one, will just be equal to infinity itself. The more it becomes longer, or the longer it becomes, rather. All right? That's infinite. Now, if we divide a certain value, let's say c is a constant, whatever the value of c is, if we divide it by a certain value with an infinite exponent, this value in time approaches what certain value? If you divide c by 100, if you divide c by 1,000, if you divide c by 1 million, the value approaches closer and closer to becoming what? Exactly, 0. Okay, since we do not know the time, so we can assume that if we talk about infinity, the value c over e to the power of infinity will become infinitesimal, it will become very, very, very small. Okay, to the point that it would not anymore be significant because it will become 0.0000 and so on. It will not anymore affect the values. In other words, we can now say that your q of t over a long period of time will just be equal to L over 1 or just equal to L. So these are the numbers of computers infected over long periods of time. Do you follow? To get the percentage, it will just be the L by which we got the value of 165. What was the value again? 165,620. 165,620. These are the number of computers infected over the population of 2.6, 2,600,000. Okay? So what percentage of the population are the number of computers infected times 100%? And this gives you 6.3%, 34, 37%. So it depends on what value you're using. All right, let's say 6.3712%. So this will be the number of computers infected. The percentage, rather. All right, and that's it. Questions, clarifications? Okay. And that's how we finish this paper 3. For tomorrow, I'll be giving you, because I'd like you to practice paper 3. So I'll give you one problem only for tonight to work on for tonight. Please try your best to work it on because tomorrow, instead of me discussing, I'll be calling you to present your answers on each section. So I'll send it here. Let me just end my recording.